my pleasure to introduce Professor John Clarkson, who is Professor of Engineering Design at Cambridge, Professor of Healthcare Systems at Delft, Director of the Cambridge Engineering Design Centre and Co-Director of Cambridge Public Health. His research interests are in the general area of engineering design, particularly the development of design methodologies to support inclusive design and health systems design. He led a team from the Royal Academy of Engineering to develop Engineering Better Care, a systems approach to health and care redesign and improvement, and chairs the Academy's systems approaches in the policy working group and provides system training and support to their policy fellows. So, John, the floor is all yours. Have fun.
So, I'm going to talk about engineering better care with the subtext that systems at work do not just happen. So thank you for your kind introduction. I'm honoured to be here to give the Philip Macpherson Memorial Lecture. And it's clear that Philip did many things for Nkosi over the years. And in looking up his background, I found this description. His lasting contribution to systems engineering is a clarity of understanding and quantifying the dynamic relationships among and within complex systems. And I was quite inspired to find that, because I think what I'm really going to talk about today is the first of those two, about the clarity of understanding. And I've made it my business the last decade or so to try and figure out how to talk about systems engineering with people not trained as engineers. So I'm going to split my lecture into three key parts. So the prologue is just telling you where I've come from, and I'll leave a few clues as to why I've learnt how to be a systems engineer and what that led to later. Then the core of it, the bit in the middle, is about engineering better care and what that led to and where we've been using it. And then some final thoughts for the future, focused around health and healthcare. So I was a lucky lad, grew up down in Somerset. And I went to an extraordinarily old school where I was actually professionally trained to be a musician, but had an interest in mathematics. So didn't end up being a musician, but ended up being an engineer. And my first job was to go and work for English Electric Valve Company in Chelmsford. And I worked on a variety of things. And the thing on the left-hand side is a Ledicon. It's about yay big. It's a camera tube for use in studio cameras. The thing on the right is a Klystron, stands about yay high, and it's for broadcasting TV around the nation. These are sculptural electrical components, and that's where I started my engineering career. I went back and I studied engineering at Cambridge, and I did a PhD in stepping motors. And my particular interest was to try and understand why there's a breakdown in the performance at the high-speed end of the stepping motor. It has an instability. It took me 18 months to figure out the second of those two equations. They're both approximations. The first one's the torque of the motor, the second one's the derivative of that torque. And I could draw both of those. So the torque on the left is the map of switching angle against speed, and the thicker green line shows where the motor wants to behave. The one on the right is a torque derivative. And what it actually is a measure of is damping. But it's damping from the electrical performance and the interplay between that and motion. And where that red patch gets large enough and negative, it overcomes the mechanical damping of the system and it's unstable. And nobody had figured that out before. That was my PhD. So where the line crossed the red patch was the bit that was interesting. I then went to work for PA Consulting Group and got involved in the John Smith bitter. Tasting was extraordinarily fun. Did a lot of work in medtech as well, so we put a computer inside this discus inhaler for clinical trials work. I did a lot of automation work, and we developed all sorts of machines, and this was for testing an asthma inhaler, a new asthma inhaler. But the project that gave me most fun was working for the Royal Navy and developing the control systems for a fire training unit that worked with real flames and smoke and extinguishment. And through all of that time, what I learned was that engineering is only two questions. How can we do it better, and what could possibly go wrong? And I think engineers are particularly good at balancing the answers to those two questions. But what really caught my attention was it's all about the process. The way you go about answering those questions has a lot to do with the quality of the answers. So with that in mind, about 30 years ago, I went back to the engineering department in Cambridge and joined the Engineering Design Centre, whose primary focus is about how we improve the design process. And I've done many, many things over the years, but I'm going to focus just on two, on inclusive design and healthcare design. And I think you'll see some of the clues that map forward into engineering better care. So inclusive design was really focusing on the first of those two questions. How can we do it better? And we get excited by different products. That happens to be a Jaguar F-Type, and I've been around the track at Gaydon on that. It's an extraordinary vehicle. I find this jar of jam at least as exciting as the car. It's an extraordinary thing from Dewars. It says it's easy to open, and it is. It's based on the old Kilner jar principle and is exactly what it says on the tin, and very easy to put through manufacturing alongside a standard jar. So inclusive design starts with that premise that it's normal to be different. And in the early days, working with the Royal College of Art, we thought this was all about people who were excluded. And exclusion happens when the demand made by the product or the system or the service is greater than your ability to respond, and you feel excluded. So we thought if we could reduce the level of exclusion, reduce the tail of the curve, job done. And there's all sorts of inclusive products out there. That's the Ferrari Enzo 2. And the marketing director was on record as saying that was designed to be inclusive. When the door opens, it takes away a part of the floor sill, a good part of the roof, to make it easier to get in and out of the vehicle. Simply because the average age of a Ferrari Enzo 2 driver is in the high 50s. Roberts did something similar but more subtle. The radio on the left is the old analog radio. And all people of a certain age know how to use an analog radio. So their new digital one on the right was seen to be a mimic of the old analog radio. And under trials, most older people are able to use the digital radio, except for the fact you have to tap the button to select the station. So they made great efforts to try and be inclusive. What we learn from all of this is it's not just about the tail of the curve. The things that cause exclusion, we know, cause difficulty or frustration with others. And it almost becomes a majority issue. If you can be inspired by the things that cause exclusion and make them better, you simply make the product better for everybody else. And that's the way we now talk about inclusive design. It's just better design. And we've developed things like gloves and glasses to help empathy with some of the challenges that people face. We have a calculator so we can estimate exclusion, and that helps people understand whether they can make things better. And just one example of many things we've done. Recently, we've been working on a new international standard on the hero images used for online shopping. And the old image is the one on the left, and typically they're just a photograph of the product. The one on the right complies with the new standard. You exaggerate the things on the product that make it easy to recognize, and you tell people precisely what size it is, whether it's conditioner or shampoo, for example. And we know that the people using these new standard images sell more product. And it's easier for everybody. It was designed for people with visual impairment, but it's easier for everybody to buy the right product. And then there's healthcare design. And where we started out on this was very much the second question. What could possibly go wrong? And we've been doing work in this space for a long time, but it was really triggered by a report commissioned by Sir Liam Donaldson, who was the Chief Medical Officer about 20 years ago. And it was in response to challenges around patient safety. And we wrote a report, and the subtitle was A System-Wide Design-Led Approach to Tackle Patient Safety in the NHS. You can find that online. It's brilliant, it's written for engineers, read the pictures. The pictures are stunningly good. So for example, there's a bottle that says, human beings make mistakes because the systems and processes they work in are poorly designed. or too many healthcare solutions have been designed based on a paucity of knowledge of the system into which they will be placed and the needs of the people that will use them. So this was reporting back through the NHS, and the copies of this report went to most medical practitioners. We've used engineering risk methods in a lot of areas in healthcare. One was with Almus Pharmaceuticals. They introduced colour into the packs to make it easy for the pharmacist to select the right medication. And we were interested in whether that would compromise the safety of the patient. And if you took one of those medications, if you stare hard enough, you'll see it says in the middle of the pack, take only once a week. If you take that particular medication daily, you die horribly. And it's used a lot for treatment of arthritis. So we worked with the National Patient Safety Agency, and there was a death about 25 years ago near Cambridge, and this medication is a hazard and it can cause harm. And that particular death, we looked into it, and there's about 15 things went wrong that conspired to kill that patient. And on the back of that, we looked at all sorts of things that could be changed. Rebranding the medication, changing the shape of the tablets, changing the software for dispensing. And all of this came out of taking engineering-led methods to look at safety. So that brings me to engineering better care. About 10 years ago, the Royal Academy of Engineering asked me to chair a committee. And the exam question for this committee was to work with the health and care professions to explore how engineers can add to current understanding and practice of systems, engineering in quality improvement and healthcare design. And Richard, wherever he was in that committee. And we worked with the Royal College of Physicians and the Academy of Medical Sciences. Typically, we ran workshops with about 50 people in the room, 2/3 health and care professionals, 1/3 engineers. And we started from this premise that systems at work do not just happen. They have to be planned, designed, and built. And I like the ambiguity of that in healthcare, where you have a system and it's developing and changing, and yet that, I think, still holds when we're trying to improve health and care. Very early on, we brought the V model into the discussions, and I think it's utterly brilliant, and I'll come back to it later on. But it didn't work with our health and care colleagues. It's too complicated. So what we started out doing was just looking at perspectives on systems thinking, engineering approaches, and saying, let's think about it in terms of systems, design, risk, and people. And we ran a workshop in each of those areas to explore what the engineers and what the healthcare professionals thought about those perspectives, what the stories were, what we actually did. And out of that came some key messages. So a brief summary of each of those workshops. Systems. Systems of systems. Healthcare professionals get it. It's the waterproofing system, the plumbing system, the neurological system. The whole is far greater than the sum of the parts. But we can also think about the patient going to see the GP with some ongoing condition. The GP looks up the formulary or uses software to generate a prescription, which they give to the patient to take to the pharmacy. And the pharmacy gives the patient the medication which they put in their system at home. And the questions that came out of this dialogue were to say, well, who are all the stakeholders who have an interest in that system and have to do their jobs to make sure it all works, that the patient gets the right medication in the right dose at the right time? What are the elements or parts of that system, and how do they fit together? And how does the system perform, or how would you wish it to perform? So that was just from the systems perspective. From the design perspective, we were inspired by the double diamond model from the Design Council. And I particularly like that picture because it has that challenge built into it. So you need to spend as much time thinking about how you translate the need to a definition of the problem as you do trying to find the best solution. And we can apply that to something as simple as blood pressure monitoring equipment, or a piece of equipment in a suite of equipment in the complex environment of theatre. Or we can apply it to the GE 750 scanner, this one set up for use by children. You promise the child an undersea adventure. The rumblings of the scanner are put down to the engine room of the submarine. And you ask them to be as quiet and still as they possibly can, so nobody knows they're down there. And success is the child so excited they want to come back tomorrow and do the whole thing again. And you get a brilliant scan image without having to sedate the child. Or we can apply it to a defibrillator for use by the general public. Not only does it have to work first time, but the instructions have to be intelligible by a novice to make sure it works first time. And the questions that come out of that, you could say, well, what are the needs? How can the needs be met, and how well are the needs met? And that was inspired by the work we did on inclusive design. And then there's risk. In health and care, we want the outcomes to be normal. And risk is generally, typically about understanding the threat of accidents and trying to avoid them. But it's just as much about looking for what we do that's exceptional, and how do we learn from that? How do we shift that curve to the right? We can apply that to simple things like central line insertion. And we've stared at this process long enough that we know that there's a particular point in the cycle, if you interrupt the operator, they forget whether the wire they're about to grasp is in or out of the patient. And it doesn't kill people, but it's really inconvenient after surgery to have to go back in and find the wire. Infusion pumps cause some grief too. There's a pump on the market that if you try to tap in 15.7 and you tap in 15.5 delete 7, you've actually put in 157. And it's put down as an operator error, but it's an extreme error of design, and there are many other examples like it. A changeover of staff on a busy ward. What could possibly go wrong? Or what can we learn from that we do particularly well? How do we use engineering methods in a social environment? And sometimes people just make mistakes. This is Hamilton, Malaysia, 2013. Just switch from driving with McLaren to driving with Mercedes. Comes into the pit, first time in the race, stops at the McLaren pit crew, and they just have to point him down the line to the Mercedes crew. So how do we design systems that accommodate natural mistakes? And the questions that came out of this is, what is going on? That duality of what could go wrong, what do we do well, and how can we make it better? And this borrowed from the risk work we were doing previously, but it overlaps into the systems and design thinking. And then people. We would think about diversity within the patient population, but also the provider population. And why is it we give people with arthritis medication in child-resistant containers? That's the same picture as before in the morning without your glasses on. One of those medications is methotrexate, and if you take it daily, you die horribly, and we conspire to make them all look the same. And what about language? Is it clear, consistent, correct? Through our whole lifetime of engagement with the health and care system. And if we change something on one particular ward, should we expect it to work on the ward next door, or across the hospital, or across the region? It's not clear that we should. And the questions would be, well, who will use the system, where is the system, and what affects the system? And it could be policy and regulation, for example. So these are all the questions that came out of these workshops. And it's a bit like the juggler, that the performance is really only complete if you keep all the balls in the air. We can assemble those questions. They have a natural order, starting from the top, working clockwise. And the majority of those on the right are problem-seeking, and those on the left are problem-solving. We overlaid that on a very simple development curve, going from current performance to something measurably better. And we thought of those questions of wrapping around that process, and at the front end, particularly looking at the problem-seeking, moving into problem-solving at the back end. And that was what was published in Engineering Better Care, with a few observations from the workshops that the healthcare professionals were really surprised that engineers think about people. But it's what we do most of the time. That they understood that we thought about iteration before implementation, that design was an exploratory process. The risk management was proactive. What could possibly go wrong, as well as what went wrong and why? And then thinking changes practice. That use of questions was a deliberate attempt to try and change the way people would think, but they wanted some sort of process to go with it. And I'll come back to that. And the number of times people said to me, John, there's nothing new here. It's true. It's not rocket science. It's just common sense. But when you look around, common sense is not common in applying these ways of thinking in health and care improvement. So if you look up online, you'll find the Engineering Better Care report from the Royal Academy of Engineering. There is a paper version, a PDF you can call off online, and there's an interactive version. So everything you've seen so far is in that report. But it's a description of what a systems approach is, not how to do it. So I took that work back to my own group and said, well, we need a toolkit. We need to describe what we might do in practice. So the first thing we did was put a process in place. You need to understand the context, define the problem, develop the solution, collect the evidence as an iterative design cycle, underpinned by making the case to allow you to do it, managing the plan to deliver, but above all else, agreeing the scope of what you're trying to do. We superimpose that on the same process from the current performance to something measurably better. And that introduces a few more questions that define where you're starting from, where you might aspire to get to, and what you measure when you get there. So we now had 21 questions, and the one at the middle is, what should we do next? And again, predominantly the questions on the right are problem seeking, and those on the left, problem solving. Now, at this point, we scared people off. Too many questions. So what we did was a very simple thing and superimposed them around the process model. And suddenly people started to get it. You could situate the questions at different stages of the model. And what surprised us is that about half those questions were about context and the problem. And I think that's where this particular systems approach can add its most value, is helping people understand the right problem that they should be solving. We then thought, well, questions on their own are not enough. What are the activities or tools that people might use to answer those questions? So we looked in a whole variety of places, inspired by a lot of prior research on design, to say, well, where do we find those answers? And there's a whole bunch of activities that we then put around that model to help people answer the questions. In the toolkit we created, there's playing cards that remind people of different stakeholders to help them think who the key players might be. There's other cards that talk about activities, tools, questions, and language. There's templates that help them answer those questions and use the tools in practice. There's posters that remind them what they should be doing and how they should be inspired. And we got all this ready for February 2020, so a month before lockdown. Everything was ready to go, and within a month we had to put the whole thing online and start training people online. 2 years later, we had the privilege of going up to Lancashire and South Cumbria, working with a team up there, and there was 5 hospitals came together to look at frailty in their population. They had their own process they put together. It followed the same stages as in our own process. And they put together a 2-year program, nearly 2 years, to try and educate people across those 5 trusts on particular projects around frailty. And we were called in to help run 4 workshops. One on sort of launch and setup, one on understand, one on co-design, one on delivery. And we taught them a whole bundle of stuff. And I'm not going to go into the detail, but lots of things we taught them to do, worked with them, mentored them, coached them to use them in anger, wrapping ideas around their existing processes. So, for example, they used Improvement Canvas, which is a version of the hexagon model that allows them to identify the problem. They had a lot of fun doing rich pictures. Hugely informative and helps build the teams working together. The bow tie method to look at early ideas around risk for the solutions they're putting together, and lots of planning activity. But the key to it was the setting up of a think tank and a do tank. So I chaired as an external the think tank, where we owned the systems approach and the co-design and development of that. And we had a do tank run by one of their development leads to support them in actually running their projects. We started with 4 projects in 4 hospitals and added 4 cross-cutting regional projects, all driven with a systems approach. But that separation of process and practice was hugely important and helpful for them. We talked a lot about systems leadership. And this phrase will be familiar, that the systems leader at any stage of a change cycle works with and between their teams and the other teams at equal, lower and higher system levels to ensure a smooth delivery program with no surprises or adverse consequences. And we thought about levels of leadership and thinking, well, how would we raise people up through those levels? And we thought, well, engineering better care might give them awareness. Giving them the toolkit and training them to use it might get them up the next couple of steps. But we needed to find a way to create systems leadership across the NHS. And particularly with the challenge that it's about how you lead across boundaries. When you're not in charge and need to influence others, and where no one person or organisation can find or organise a solution on their own. And that's a particular challenge within the NHS and the broader social care. All the while through this, we worked with John Dean, who's the Vice President of the Royal College of Physicians. And he worked with me on the initial Engineering Better Care. And he observed that engineers working with healthcare professionals have insights that are different from the current understanding and guidance available, and can build on existing practice to make systems safer. So he's been a real advocate in how we translate all this work into practice. What came out of this was a second version of the toolkit, a co-design with the practitioners. The sharp-eyed will now see there's an additional fifth stage, the initiate stage. So we had to think about how you even set up the project in the first place. So we have 5 stages. We represented them as diamonds. I don't like the linear form of it, but we did build a lot of iteration into the practice. We took those questions and we created a spiral to say, well, different questions have different emphasis at different stages. And we wrote some guidance. I got told off with this. I said, we should have had this at the beginning. But we co-wrote that with them because they really wanted things simplified down to say, what's the focus of the questions and the activities at each stage? So I'm not entirely happy with this, but this is still work in progress. We focused around different access points for the novice, the expert, and the leader. We created a lot of material, many sleepless nights, created a physical toolkit, and the version you now see online is the latest version of the toolkit. I still see that as a prototype. It's a starting point for conversation with health and care professionals to say, well, how do we co-design the better version? How do we help this wrap around what you do? So where have we been applying this in practice? So many different places. So I've talked about Cumbria. We were looking at frailty, and a couple of the outcomes there is that they looked at using a standardized clinical frailty scale across the whole region, which they were not doing before. And we worked with them to create personas to help them implement that in practice. They now have a strategy and vision for frailty care in the Northwest, driven by systems thinking. We also worked with number 10 with a task force on discharge planning. The exam question there is that people come from the community, they come into the hospital, you're trying to get them back into the community. And the particular focus here was where they need care as they go back into the community. So we needed to understand what was happening in the trust and what was happening in any discharge planning. To cut a long story short, nobody knew what was going on. And 40 plus interviews later, that was the map from Kettering Hospital, trying to understand what was going on. And that was later converted to a rich picture with the Academy. And you see at the front there that you've got admission, treatment, and discharge as the 3 key steps in the hospital. And they're trying to improve their flow back to the community. But you see everything else in the community is connected to that and has a dominant effect on how they can perform. And any hospital that tells you they can improve flow without working across the wider system don't know what they're talking about. So I'm continuing that conversation with my own local hospital and several others around the UK. We've used the toolkit to improve the patient experience on discharge from mental health care. We're currently using it to see how we encourage people to take up pulmonary rehab as part of their treatment. We're also looking at a technology that can tell you that you're going to get dementia probably a decade before there's any clinical signs. And that's a systems challenge. How do you develop the clinical systems around that knowledge of the patient? We also have a footprint up on the hospital site, and this was during COVID, surgical team and designers talking about reusable face masks. As another team in my group looking at international health systems and applying a systems approach to everything they do internationally, and currently looking at developing trauma care guidelines for the WHO. We've also used it in helping those that advise on research design, how to use a systems approach in designing the research that they do. And storytelling has become a major part of that way of thinking. And you said in the introduction that I'm working with the Academy, that the Academy now has policy fellows, and every single one of those policy fellows in the first day on the job is trained in a systems approach. So we provide a half-day training, then I mentor them in applying that in their policy challenges. And one of those policy challenges was the Scottish Government switching from oil and gas heating to heat pumps in the home. And through long discussions with them, we realized that they needed a set of personas that they co-designed to describe the people affected by this policy. And in doing that, they realized they had to radically rethink what they did next. And they completely redesigned their communication process about the policy. And they had to rethink who was actually going to serve the community with these new heat pumps. We've also been using it for work out in the fens, looking at water conservation, using the same approach. And in education, we've been developing modules for teaching at Key Stage 3, design and systems thinking, and there's a new master's program in healthcare innovation that has at its core systems approaches. So if we then look forward, where are we heading from there in healthcare? I think there are three obvious things, and probably many others as we go forward, that we have a changing demographic around the world. There's an increased use of digital technology at multiple levels. But what the pandemic showed is that there are inequities of care that can emerge as we start to go digital. So you've all seen these sorts of graphs. This is the proportion of the population over 60 rising all around the globe. We know that digital health is on the way in terms of data, in terms of technologies for diagnosis and management and so on. So my interest is how we take a systems approach and ensure that we continue to provide new technologies for healthcare professionals that are genuinely fit for purpose, technologies that can be used with patients. And they could be complex technologies, they could be simple technologies. This is an addition to an inhaler designed by children in schools, for children in schools. It's one of the biggest killers in the UK is childhood asthma. But by asking children to take a systems approach to designing this type of intervention for themselves, it is beginning to reduce that challenge. And as I've been looking around and reflecting on this and getting involved in various committees around the UK on the use of AI in healthcare, for example, I've been reflecting on the challenge that as we put new technology out there, we know there's this interplay between capability push and opportunity pull. But I'm not sure how balanced that is at the moment. Typically, what we see is people say, I have what you want. The technologies are pushing things. And that can be extraordinarily effective when we're looking at the use of AI tools in diagnostics and imaging. There's some really good work coming through there, but we know that human mind is still required. I guess what I'd like to see is a bit the other way around. Can I tell you what I need? Can we talk to the health and care professionals and really understand what challenges them at a local level, at a hospital level, at a regional level? And what I don't see is a common understanding. So particularly with things like AI, I see people who understand the technology deeply, pushing solutions funded by government. I see very few healthcare professionals who understand AI to the same level, seeing the opportunity for drawing it in to solve their problems. So what I'd really like to see is a double-ended arrow, and it's all about the conversation, that we raise the awareness so it's more of the pull than the push. And there are people who are doing this really well. There's the Helix Centre, set up by the Royal College of Art and Imperial College at St Mary's Hospital in London. And one of the co-founders was Aradazi. And it's a conversation place. This is a hut on the pavement outside the hospital where you can bring the physicians together with designers, trying to understand each other and come up with better solutions for health and care. And I hope in some small way the toolkit we've created will enable those conversations, that it's pitched at a level that allows people through natural language and questions to engage in the issues that really matter. And I think at some sort of national level, we really should be thinking about this think tank, do tank in health and care. Have a team of people co-designing the future systems approach that's going to make the difference, alongside supporting and training and mentoring, coaching people at the coalface trying to make change. So, final thoughts. I collect pictures of design processes, and I tend to show them to people. So I like this architectural design spiral, that sense of being lost in the fog, and eventually you end up with a concept and you move forward. And whoever I show this to, who does improvement or design, says, I know that feeling. Then I show them the naval architectural design spiral around a more conservative approach to design. And the same people will say, I know that feeling, I know that process. And it's really interesting that they emphasize different things. You show them the double diamond and they start to understand where they might be, typically at the right-hand side. And there's real value in going back and thinking about the left-hand side, particularly in the new systems-inspired version of the double diamond. So we put together our own pictures, the juggler looking at the perspectives, the set of questions, the process model. And then I keep now coming back to the V model, particularly with the people I've been working with for a while. And I sat down and I just thought, well, what is it about this picture that inspired me so much as an engineer in practice, that had a lasting legacy that I keep coming back to, and I want to come back to more than I have done in the past? So I looked at what was in the picture, and I think there's the language of the core journey that starts with need and requirements, and it talks about verify, validate. These are words that dominated my thinking in practice and drove what I was doing. I think the double-ended horizontal hours are utterly inspired. To be able to say to a healthcare professional, you need to know how you're going to measure success, and that may affect what you do in the first place, I know was practiced from the engineering world. And that's an argument I use a lot now with people, to say you must be thinking ahead right at the beginning about what you're going to do at the back end. I think the 4 key statements are incredibly helpful. Understanding the problem space, understanding the solution space, assess system value, assess system cost and risk. Those are really important messages for health and care professionals and policymakers about what they should be doing. And my predecessor who taught me design said, look, John, you only really understand the problem when you find the right solution. And I think having both of those on the map and playing on that duality is really important. And then there's the bit I keep hidden most of the time. When I'm talking to healthcare professionals, I want them to dream. What does good look like? What's the best that they can provide without worry about constraints? But then you have to bring this piece in and say, look, well, that's where you want to go. How far can we get towards that, taking account of the constraints? So there's many things about that picture that are utterly inspired. I think it's a brilliant diagram. And I'm still learning how to communicate the benefits of that picture of what is systems engineering in a way that's more accessible for non-engineers. And I will continue to strive. Some of the work that Philip McPherson was doing is that clarity of understanding. Because I'm absolutely dedicated to the idea that we must be thinking in terms of systems, in design, risk, people. And that should affect everything we do, and particularly if you're in the world of policy or the world of health and care provision. I think it's such an important thing to do. And that's what I've been doing for the last 10 years, and I will be doing until they wheel me out in a box. Thank you.
Thank you, John. That was absolutely fascinating. We've got time for questions. We've got Andrew and John with roving mics, so if you have a question for Professor Clarkson, please put your paw in the air. One over there.
Hello. Paul, thank you very much for that. Paul Davis, the systemengineer.uk. One of the constraints in your bottom left-hand corner that you can never ignore is budgeting. What I wanted to ask is, have you managed to get the finance community inside the solution space rather than as part of the problem space? If I take the example of integrated health and social care, for example, everybody thinks it's a good idea, but at the top of every trust it says, yeah, we need an extra level of integration there, it needs funding, and I don't have a budget for it.
It's a great question, and it's one that is often challenging in health and care, where the problem you're trying to solve is outside of your jurisdiction. Now, we now have the integrated care partnerships, which are part of that solution. I just don't think we're there yet, but the way that we are working on that is to make sure that we bring the key stakeholders into the room. So if the hospital's looking at flow, we will make sure they bring in people who are providing the community care part of it, so that they understand each other. And to give you one example, that if you are a patient in the community with a care package and you need to go in for standard surgery, after 48 hours in hospital, you lose your care package. A day later, you may be medically optimized and ready to go home, but you have no care package. And you think, well, why? How can that be? And yet, those providing the care in the community, they realize they have some resource released, and they provide it for the next needy person on the list. They're only doing what their bosses challenge them to do, which is to maximize the use of the minimal resource they've got. But it's not aligned to what the hospital's trying to do. So the only way you solve those types of problems is to make people aware that people are not malicious in what they do. They're just doing what they think they should be doing, but they need to have those conversations. And it's only then you might have a chance of unlocking that sort of challenge. So in answer to your question, do you want the finance people involved? Absolutely, right from the start. They are stakeholders in the room.
Thanks for the really interesting talk. William Eastown-Babb from Oxford Hypnotics Limited. I was talking to a junior doctor the other day who was saying that at her hospital they're still often using faxes for kind of sending information between different hospitals or different sort of healthcare parts of the system. So I'm just wondering, kind of, what do you think are the main barriers to sort of more effective systems across the NHS?
Well, I'm going to have to be very careful what I say at this point. Connecting up hospitals and data remains a big challenge, has been for a long time. The solutions out there are few and far between and very expensive. And you often end up with hospitals using different technologies. So on the Cambridge site, we have the main hospital, we have the Papworth Hospital, and they use different systems. They generally would print out the patient record and send it with the patient between the two hospitals. I still think we've got a long way to go to solve that problem, but we are making some inroads. Not an easy one, but it remains a big challenge.
Mark Ashforth, I'm Senior Scientific Advisor at the Aerospace Warfare Centre, which comes under the RAF. I wanted to ask a question related to this slide you showed about the requirement pull and the solution push and the need for conversation. And I think especially in terms of something like artificial intelligence, which you mentioned, there's all the hype about it and there's all the fear about it. Very difficult to have that conversation in terms of that, what do you want? Well, what can I have? And what would you say more about that conversation, how best to run that?
So I've been in workshops organised by the Academy of Medical Sciences about this topic. And there's a lot of technologies present, pushing technology funded by government. And that's laudable, some really good things happening. And the few medics that join that conversation know something about AI. I know if I go to the hospital trust and say, what are the challenges, the key top 5 challenges that face you as a trust, I get a very, very different list of challenges. And one of them is about managing flow of patients through the outpatient clinic, for example. So if we could get the right people in the room just around that problem, and the AI community saying, look, these are the types of tools we've got, these are the sorts of things they can be applied to, but be listening to the health and care professionals about what a hospital or a wider regional service is about and where the real challenges are, I think we'd see some different solutions emerge. And the problem is it comes down to the money in the end. There has to be a way of monetizing whatever it is you put into the hospitals. But the value of increasing flow of patients through the trust would be phenomenal. and it would satisfy many government targets. And yet somehow we don't seem to be able to join up those bits and pieces. But it's an ongoing conversation, and the Darcy report was extraordinarily good in unpacking some of the challenges out there and not pointing the finger at people. And I think the response to the Darcy report is already talking very, very much about a systems approach and how we bring the right parties to the table to solve some of these challenges. Again, it's like with the data, we're not quite there yet.
Hi, I'm Kath Lane from BA Systems. We often draw the V model as a V with an endpoint, but given the budget constraints within the NHS, through life cost of ownership must be a massive driver. So how have you built in through life capability management into your whole process model and approach? So it's not just the solve the problem now, but it's about thinking about the long-term cost implications of those things that they're putting into place.
It's very much about getting the right people in the room right at the beginning. And it'll be a number of the people on the board, the directors, it'll be the development director, it'll be the finance director, the COO. It's getting the senior people engaged in those conversations early and really teasing out which are the parts of the problem you are going to own and try and fix now, and what the implications might be. But again, it's not that straightforward. I sit on the strategy group at our local hospital, and strategy goes only 2-3 years out. It doesn't go far enough to fix some of these big challenges. But the starting point, and we keep coming back to this, is have you got the right people in the room? And my job, in a sense, is done if I can double the number of people in the room by bringing those that they didn't think they needed but are absolutely essential. We've started on that route of taking a proper systems-based view. Again, it's not one of those things that's easy, but I think the people who own the problem do understand what you're saying. They do want the top-level cover, and they would actually be far happier to have those people involved early who want to solve the problem with them. But I think it's just educating people to think differently to the way they've been told that they need to think within an NHS framework.
Morning. Craig Spencer from Synoptics. First, truly great presentation, thank you. We can find that when we go outside of traditional engineering applications, so NHS for example, people can be initially a bit resistant to, you say, oh, we do engineering, and people go, oh, no, don't want that, thanks. Have you kind of found that in your experience with kind of entering sort of healthcare, and how do you kind of get around that if you did?
You need several things. One is you don't talk about engineering, I talk about design. So that makes it a little bit easier, and you need absolute humility to ask stupid questions and just try and learn what they're talking about. And I think, to be fair, though, that I put surgeons in one or two boxes. And as one type of surgeon comes along and says, I need one of these. And it doesn't matter how many questions you ask, how much you engage in conversation, that's what they're going to get. And the other type of surgeon, you say, well, why do you need one of these? And they'll start to unpack the discussion. And you eventually come back to what the need is that sits behind it. And you probably deliver something completely different. So I think that there are natural blocks. Some people just will never get the need for that dialogue or conversation, but the majority do. And I think as an engineer, you do think differently, and the challenges you can put on the table do make people think. So I talk about resilience in the strategy group in the hospital, and I can unpack what that means from an engineering point of view, and it opens their eyes, and they want to know more about what it is. So I think I don't use the term engineer. I go in as a systems thinker or a designer, and that people go to sleep a bit more slowly.
Hi, I'm Tony Richards, MBDA, but also St John Ambulance. We in St John have had a lot of issues where people have gone, oh, we want tool X because that's what the London Ambulance Service use, and so it works for them. Did you face much of that elsewhere in the NHS, and if so, how did you get past it?
In terms of the way people go about improvement, there are different models that people use. There's the IHR model of improvement, there's lean thinking for healthcare. The standard ways people are trained, and you ignore that at your peril. That's the way they've been trained to do improvement. So what we try and do is to take these questions and wrap them around what they're doing and show them where asking these questions can add more value, add something to what they're doing, rather than tell them they shouldn't be doing it. And I think that's the key. Start where they're at. They've been taught to do it, to stage it in a certain way, but how do we make what they can do even better? Now, sometimes I'm a little bit more critical than that about their methods, but I think that's the right way to think about it. Yeah.
Morning, John. Rob Valentine, Atkins Realis. On a more sort of practical level, have you got any advice on how to keep stakeholders focused on what they need, not what the system needs to be?
Oh, that's a really good question. I think I'll answer it a slightly different way. When we ask stakeholders what their needs are, we say, as a, I need so that. And the so that is fundamentally critical. So you're trying to distinguish between the wants and the needs. And we're also trying to have the difficult conversations early, to say there's a whole bunch of needs that people say that they have, but not all of them can be satisfied all the time. So we're trying to figure out what is that combination of needs that becomes the requirements very, very early on. But first of all, trying to distill out, I must have one of these because, no, what do you really need and why do you need it? So it's part of that early way of thinking. People latch onto that really quickly and they like it a lot. That it gives the reason behind those needs, and then only some of them follow through to the actual project.
Final question.
Good morning, John. It's Aaron Jones from BAE Systems. So my question is in regards to the V model, and what is the benefits of having early validation, and is there a correlation between having early validation and the horizontal diagram, horizontal diagram on the presentation from research concept and the straight horizontal line in design?
So I like to distinguish between the verification and validation, particularly because the one is just a response to requirements, the other one is a response to need. When you're talking with healthcare professionals, it's really important to come back to the need and saying, well, how would we measure that we meet that need? And a very simple example is an asthma inhaler itself. You can specify how a fluid asthma inhaler works in terms of droplet size, the spread, the amount, the engineering characteristics of how an inhaler should work. But you can also validate whether it is fit for purpose, whether when used by people, it actually alleviates symptoms of asthma. So I think right from the start we have that duality of conversation, saying, well, what are the things we can directly measure against the requirement, but how do we know it's actually fit for purpose? And I use the term fit for purpose a lot with health and care professionals. And so right from the beginning, that's part of that conversation. And the V model just supports that because it has those arrows right at the top of the diagram, separate for verification and validation. I think the bigger challenge is how many V models do you need? And that's the one I've always wrestled with, that complicated projects require multiple Vs that then nest back together. And that's an even harder conversation with the healthcare colleagues. But validation, that's not a difficult conversation. I think they get that.
Okay, thank you, John. Fascinating. Can you show your appreciation? Thank you.